everyone. In the previous lecture, we were discussing about the different levels of theory of computation, right? So in this lecture, we will give some brief introduction about those levels, and we were. I hope you all remember that levels. The first level is the FSM. This is the simplest one, and then we were having the PDA, and then we were having the Turing machine, and the last level is the undecidability. I hope all of you have remember about these levels, and today we'll discuss each and everything. It's not like detailed lecture, just I'm giving you the brief introduction about that particular level. Okay, the first level is FSM, so finite state machine. So we'll see what is finite state machine. We otherwise we can call this FSM as a finite automata. So finite state machine, or you can say it is finite automata, or simply you can say FA. Okay, this is the simplest mathematical model. See, before going into depth here, theory of computation is based on computational mathematical computations. Okay, these computations are used to represent these models. Okay, see, have in mind that theory of computation, we are going to build the model. Okay, it's not like physically, we are just giving the mathematical model of the particular machine. Okay, so this is like people were taught these things 50 years back. Okay, so 50 years back, so we are just revising those concepts. So here finite automata is the simplest mathematical model that consists of number of states, and it will have the input symbols and transition function. This input symbols is given to the input for that particular finite automata, and this will be passing the states in the finite automata, and this move from one state to another state is represented by the function called transition function, and then you will have start state and final state. Okay, these are all the members of the finite automata. So when you are designing a finite automata mathematically, you will obviously have these things. Okay, so when you are saying the input symbols, this input symbol is or reside on the input tab. So this is how the input tab looks like. So this is all the input strings you are giving. So when I say A B A, so this A B A is one particular string. Okay, that is reside on the format called input tab, and then this tab is read by the tab reader. The input strings are read by the tab reader, and it will also have the finite control. Okay, so this is how this finite automata looks, and this is the simplest model. So as I said earlier, finite state automation or finite state machine does not handle more number of memory, so it is the simplest model. Okay, so it was the first model came into the picture. So this is the finite automata. So next we will discuss about the PDA. So what is PDA? PDA is the push down automata. So one more thing is here, finite automata will accept, just know the terms alone, regular expression, regular language. We can say it is a regular language. This finite automata will accept only regular language. Okay, just to have these terms in the mind. So in the upcoming lecture, we will give the detail about these things. Okay, so push down automata. Next category is push down automata. So PDA, we simply call it as PDA. So this will accept only CFL. CFL means context free languages. This push down automata, as I said earlier, push down automata has the more memory compared to the finite automata. Okay, so finite automata has limited amount of memory, but here push down automata will have some more extra memory. So this consists of finite set of states, input set, and stack symbol. So stack symbol and initial state, or you can say it is start state, either initial state or simply start state. Stack starts symbol, and then you will have set of final state, and then transition function. Okay, so these are all the members of the push down automata. When you are defining push down automata, these things should be there. So the first one is finite set of states. Okay, so you will have number of states. Okay, so we'll see what is set, everything, what is language, everything detail in later lectures. So just now you just listen what is these models refers. Okay, so it's finite set of states and then input set. The first one is finite set of states and input set. So here also, like, to accept the, to read the string input set, you will have input set definitely, and you will have stack symbol and initial state or starting state, stack start symbol, and transition function set of final state. So when you compare these two diagrams, in the finite automata you only have the input tab. Okay, but here in push down automata you have one more extra memory, that is called stack. You just call this as stack. Okay, so I hope you people know what is stack. Okay, even if you don't know, when we are discussing in detail, we'll come to know what is stack. So here stack is in, it will hold extra memory. As I said, this has more memory than finite automata. That more memory is handled by the data structures called stack. Okay, so here this is the input tab. So input tab will read the input symbol, whatever you are giving, just read the input symbol. This is the input tab reader, this is input tab, and this is the tab reader that will read the input symbol, and this is the finite control. Apart from this input tab, this also have the what, stack, so which will store the values here. Okay, so stack will also, so we are just storing the input strings one by one. We are just making use of this stack for doing more number of operations than finite automata. So here in finite automata you cannot do more operations, mathematical operations, but here in push down automata you will be able to do more than computations whichever cannot able to do by finite automata. Okay, this is what push down automata. Just see the terms, and when you are building it, will understand what is these things. Okay, but third one is, the third level is Turing machine. Turing machine is, as I said, Turing machine is invented by the person Alan Turing in the year 1940s. Here the Turing machine will consist of finite set of states, finite set of external symbols, input set and start symbol, starting state, and finite set of final state. Okay, these things you cannot able to mug up. You just see the terms. When you are building the machine, automatically when you are practicing it, it will be, you can able to remember those things. But here the difference is that this is the input tab in the Turing machine. Okay, so when you are seeing these, so before that we were having two input tab, right? So when you're having are you seeing any difference between these Turing machine and finite automata and push down automata? Yes, we are having infinite tab. This side also you have infinite tab, and this side also you have infinite number of memory. So which means that you can, one point is here, note, you have to note down. So you can read the input string in the Turing machine input tab. This is input tab, right? So when you are reading an input, you can able to move this tab reader left or right. Okay, you can this reader can go this side, or either this side or this side, that is left or right. So you can move that input reader, tab reader, input tab reader left side or right side. Okay, so which means that you can able to do more number of operations, okay, compared to push down automata and finite automata. So here when you are looking at, here also you are having infinite number of tabs, here also you have infinite number of places. So which means that you can able to come up with more number of logic here. So that's what Turing machine is. So Turing machine is that much powerful. So when we are building a mathematical model, so for each and everything we'll be discussing in detail in the upcoming lectures. Okay, I hope you have got some things about these three things. So first one is finite automata, second one is push down automata, and then Turing machine. Okay, Turing machine, just remember the structure alone. Okay, structure and these terms. Okay, what are all the members of this model? Okay, so we'll see in the next lecture. Okay, thank you.